In this video, we're going to look at building profit, revenue, and cost functions where one of our functions or more is nonlinear. So in this example, we're given that the cost to produce X units of a product is given by this function right here. And the units of this function are dollars, and this part over here just tells us that our values for X that are valid, X has to just be between 0 and 1,000 units. Each unit is sold for $78, and in part A, they ask us to identify the fixed and variable costs. Now remember, when we're talking about fixed costs, we're talking about the costs that don't change no matter what your X is, and so the fixed costs are always just the constant part of your function. So our fixed costs are $4,200. Our variable cost, this is the part of the cost that has the variable. So this part right here is our variable cost. So we're going to have 0.01 x squared plus 23x. Those are our variable costs. In part B, we're asked to build the profit and revenue functions. And recall that revenue is price times quantity. And in this problem, they told us that each unit is sold for $78. So this tells us our price. So our revenue function is R equals our price, which is 78, times the number of units, and remember we're selling X units, so it's going to be 78X. Our profit function we find using this formula. Profit is revenue minus cost, so our profit is going to be 78X, that's my revenue, minus my cost. My cost is this function up here. We're going to have 0.01 x squared plus 23x plus 4,200. Notice that I don't really need to have the parentheses here, but these parentheses are required because I need to take this negative and distribute it across all three of my terms to make sure that I'm subtracting all of my cost function and not just the first term of my cost function. So my profit is going to end up being, we're going to have 78x minus 0.01 x squared minus 23x minus 4,200. And if we collect like terms, and I'm going to put them in descending order. So I'm going to put this term first. I'm going to have negative 0.01 x squared. And then here I've got the 78x minus 23x. So that's going to give me plus 55x and then minus 4,200. In this last part, we're asked to find the smallest number of units that need to be produced in order to make a profit. So basically what we need to do is find that break-even point where our revenue equals our cost or our profit equals 0. I'm going to just use my profit equals 0 function. This is the equation. This is my profit, negative 0.01 x squared plus 55x minus 4,200. I need to find where that equals 0. And if you look at this equation, we can see since I've got a squared there, this is a polynomial of degree 2, so this is a quadratic equation. So in order to solve these, we usually have two methods that we use frequently. We either factor or we use the quadratic formula. Since I've got large numbers and I've got decimal numbers, I'm not going to try to factor. What I'm going to do is I'm going to use that quadratic formula. Here's the quadratic formula. negative b plus or minus b squared minus 4ac all over 2a. So I need to identify what my a, my b, and my c are. So a is negative 0.01, my b is 55, my c is negative 4200. So what we're going to do is we're going to plug in the values of our a, b, and c so that we can solve for x. So we have x equals negative b, that's going to be negative 55, plus or minus the square root, b squared, that's going to be 55 squared minus 4 times a, which is negative 0.01, times my c, that's negative 4200, all over 2 times negative 0.01. So what I usually do is I start to try to simplify this by taking this part here, the part underneath the radical, which we refer to as the discriminant, and I'm going to figure out what that value is. So I'm going to type that into my calculator and find its value. When I type that into my calculator, I have the value of the discriminant is 2,857. So I'm going to have negative 55 plus or minus the square root 2,857 over negative 0.02. So I need to calculate what these two values are approximately. When I do the negative 55 plus the square root of 2,857 over negative 0.02, I end up with approximately 77.45. And when I do the subtraction version, I end up with approximately 5,422.55. Now, if you recall, at the beginning of the problem, they told us that our x, the biggest it could be was 1,000. So I know that this is not possible. And when I look at this value for my x, I know that I can't make probably 0.45 of a unit. So I need to decide, am I going to round down or am I going to round up? If I round down, then that would be having x be 77. And if I have x be 77, then that would mean that I would have a actual loss, a very small loss. But what they wanted was what is the minimum number that we need to produce in order to make a profit. So this would give us a loss. That's not what we want. If I do x equals 78 units, this is what I would need to give me a profit. That's it for this video. Hopefully it was helpful.